According to the National Electrical Code, Section 220.11, a single-family dwelling requires 4 120-volt, 15-amp or 20-amp branch circuits. These circuits include a small appliance circuit, a refrigerator circuit, a laundry circuit, and a general lighting circuit. The small appliance circuit provides power to 2 kitchen counter outlets and 2 dining or living room outlets. This circuit is intended to serve small kitchen appliances such as toasters, blenders, and coffee makers, as well as small appliances used in dining and living areas. The refrigerator circuit is a dedicated circuit specifically for the refrigerator. This circuit is designed to handle the continuous load of a refrigerator and prevent overloading other circuits. The laundry circuit is a dedicated circuit for the clothes washer and dryer. This circuit is intended to handle the high power demands of these appliances. The general lighting circuit provides power to lighting and other general purpose outlets throughout the house. This circuit is intended to serve lighting fixtures, lamps, and other small appliances. Additional circuits are typically recommended for specific areas such as smoke detectors and carbon monoxide alarms, bathrooms, outdoor areas, and sensitive electronics. A dedicated circuit for interconnected smoke detectors and carbon monoxide alarms is typically required by most building codes. This circuit ensures that smoke detectors and carbon monoxide alarms have a reliable power source and can operate properly in the event of a fire or carbon monoxide leak. A bathroom circuit provides power to bathroom receptacles and lighting. This circuit is typically a 20-amp circuit to handle the power demands of hair dryers, curling irons, and other personal care appliances. An outdoor circuit provides power to receptacles and lighting for the exterior of the house. This circuit is typically a ground fault circuit interrupter protected circuit to prevent electrical shock. A dedicated circuit for sensitive electronics such as computers and home theater equipment provides clean and stable power to prevent damage to these devices. While the National Electrical Code does not explicitly require a smoke detector or alarm circuit, it is a common practice and is often required by building codes. It is important to consult with local building officials for specific requirements in your area. Here's a more detailed look at each of the required and recommended circuits. The small appliance branch circuit serves countertop receptacles in the kitchen, pantry, breakfast room, dining room, or similar areas. National Electrical Code Section 210.52 B1 specifies that at least 2 20-amp small appliance branch circuits must be provided. These circuits should serve only the receptacle outlets specified in that section, and these circuits shall have no other outlets. Receptacles installed solely for the support and mounting of a clock are exempt from these requirements. The intent is to provide sufficient power for the many small appliances used in the kitchen and dining areas, preventing overloading of individual circuits. The refrigerator circuit, as mentioned earlier, should be a dedicated circuit. While the National Electrical Code does not explicitly mandate a dedicated circuit, it is highly recommended and often required by local codes. Refrigerators can draw a significant amount of power, especially during startup. Connecting them to a dedicated circuit minimizes the risk of tripping a breaker due to overload and ensures the refrigerator operates reliably. The laundry circuit is another dedicated circuit typically rated at 20 amps. National Electrical Code Section 210.11 C2 requires at least one 20-amp branch circuit to supply the laundry receptacle outlet or outlets. This circuit should have no other outlets. The purpose of this dedicated circuit is to accommodate the high power demands of washing machines and clothes dryers. It is essential for safe and efficient operation of laundry appliances. The general lighting circuit serves lighting outlets and general use receptacles throughout the house, except for those served by the small appliance, refrigerator, and laundry circuits. The number of general lighting circuits required depends on the square footage of the dwelling. National Electrical Code Section 220.12 specifies the general lighting load based on volt-amps per square foot. The total calculated load is then divided by the circuit voltage, typically 120 volts, to determine the required amperage. The number of circuits needed is determined by dividing the total amperage by the circuit's amperage rating, usually 15 amps or 20 amps. In addition to these required circuits, several additional circuits are commonly installed to meet modern living needs and safety requirements. A smoke detector and carbon monoxide alarm circuit is often required by local building codes. These circuits provide a dedicated power source for these life safety devices, ensuring they function even if other circuits are overloaded or fail. Interconnected smoke detectors are highly recommended, as when one detector senses smoke, all detectors in the house will sound an alarm. Bathroom circuits are typically 20 amp circuits serving receptacles and lighting in the bathroom. National Electrical Code Section 210.11 C3 requires at least one 20 amp branch circuit to supply the bathroom receptacle outlet or outlets. This circuit must serve only bathroom receptacle outlets and must not serve any other outlets. Ground fault circuit interrupter protection is required for all bathroom receptacles to prevent electrical shock. Outdoor circuits provide power to receptacles and lighting on the exterior of the house. These circuits are essential for outdoor activities, landscape lighting, and holiday decorations. Ground fault circuit interrupter protection is required for all outdoor receptacles to prevent electrical shock. An electronics circuit provides a dedicated power source for sensitive electronic equipment such as computers, home theater systems, and gaming consoles. These circuits can help protect electronic devices from voltage fluctuations and power surges, which can damage sensitive components. Surge protection devices are often used in conjunction with these circuits to provide additional protection. When planning the electrical wiring for a single-family dwelling, it is essential to consider not only the minimum requirements of the National Electrical Code, but also the specific needs and usage patterns of the occupants. Providing an adequate number of circuits and properly sizing the electrical panel ensures a safe and reliable electrical system for years to come. Remember to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the National Electrical Code and local building codes. This ensures the safety of the occupants and the proper functioning of the electrical system. To further elaborate on the calculation methods for branch circuit requirements, it is essential to delve into the specifics of National Electrical Code Article 220, which covers branch circuit, feeder, and service calculations. The code provides detailed guidelines for determining the minimum electrical load requirements for various types of occupancies, including single-family dwellings. Firstly, for general lighting loads, National Electrical Code Section 220.12 specifies a minimum lighting load in volt-amps per square foot depending on the type of occupancy. For dwelling units, this general lighting load is typically 3 volt-amps per square foot. To calculate the total general lighting load, the square footage of the dwelling is multiplied by 3 volt-amps per square foot. For example, a 1500 square foot dwelling would have a general lighting load of 4500 volt-amps. This calculated load is then used to determine the number of 15 amp or 20 amp, 120 volt branch circuits required to supply the general lighting. Secondly, small appliance branch circuits are required to serve receptacle outlets in the kitchen, pantry, breakfast room, dining room, and similar areas. National Electrical Code Section 210.52 B1 requires a minimum of 220 amp small appliance branch circuits. Each of these circuits is calculated at 1500 volt amps according to National Electrical Code Section 220.16. Therefore, the total load for small appliance branch circuits is 3000 volt amps. These circuits are intended to supply power to small appliances commonly used in these areas, such as toasters, blenders, coffee makers, and other countertop appliances. Thirdly, a laundry branch circuit is required to serve receptacle outlets in the laundry area. National Electrical Code Section 210.11 C2 requires at least 120 amp laundry branch circuit. This circuit is calculated at 1500 volt amps according to National Electrical Code Section 220.16. B. The laundry branch circuit is intended to supply power to washing machines, clothes dryers, and other laundry appliances. In addition to these required branch circuits, National Electrical Code Article 220 also provides guidelines for calculating the load for other types of branch circuits, such as those serving individual appliances, heating and air conditioning equipment, and other specialized loads. The calculations for these loads are based on the appliance's nameplate rating, which indicates the maximum power consumption of the appliance in volt-amps or watts. Once the total load for each branch circuit has been calculated, the number of branch circuits required can be determined by dividing the total load by the circuit voltage, typically 120 volts, to determine the required amperage. The number of circuits needed is then determined by dividing the total amperage by the circuit's amperage rating, usually 15 amps or 20 amps. It is important to note that these calculations are based on the minimum requirements of the National Electrical Code. In many cases, it may be necessary to install additional branch circuits to meet the specific needs of the occupants or to accommodate future expansion. It is also important to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the National Electrical Code and local building codes. This ensures the safety of the occupants and the proper functioning of the electrical system. Moreover, understanding the concepts of demand factors and non-coincident loads is crucial for accurate load calculations. A demand factor is a multiplier applied to the calculated load to account for the fact that not all electrical equipment will be operating at its maximum capacity simultaneously. National Electrical Code Section 220.42 allows for the application of demand factors to general lighting loads in dwelling units. For example, the first 3000 volt amps of the general lighting load can be calculated at 100% demand, while the remaining load can be calculated at 35% demand. This recognizes that not all lighting fixtures will be on at the same time. A non-coincident load is a load that is unlikely to be used at the same time as another load. National Electrical Code Section 220.60 allows for the omission of the small of two non-coincident load when calculating the total load. For example, the load for an electric range and the load for an air conditioner may be considered non-coincident, as they are unlikely to be used simultaneously. By applying demand factors and considering non-coincident loads, the total calculated load can be reduced, resulting in a more accurate determination of the required number of branch circuits. In addition to the calculations outlined in National Electrical Code Article 220, it is also important to consider the requirements of other National Electrical Code articles, such as Article 210, which covers branch circuits, and Article 408, which covers panel boards. These articles provide specific requirements for the installation and protection of branch circuits, including requirements for overcurrent protection, conductor sizing, and grounding. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect branch circuits from overload and short-circuit conditions. National Electrical Code Section 240.4 specifies the requirements for overcurrent protection of conductors. The overcurrent protection device must be sized to protect the conductor from overheating, but it must not be larger than the ampacity of the conductor. Conductor sizing is based on the ampacity of the conductor, which is the maximum current that the conductor can carry continuously without exceeding its temperature rating. National Electrical Code Table 310.15 P16 provides ampacity ratings for various types of conductors based on their size, insulation type, and installation conditions. Grounding is essential for electrical safety, as it provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. National Electrical Code Article 250 covers the requirements for grounding and bonding. All metal enclosures, such as electrical boxes and panel boards, must be grounded to provide a safe path for fault current. In addition to these technical considerations, it is also important to consider the aesthetic aspects of electrical wiring. Branch circuits should be installed in a neat and workmanlike manner, with conductors properly supported and secured. Electrical boxes should be properly mounted and aligned, and all wiring connections should be made securely. A well-designed and installed electrical system not only provides safe and reliable power, but also enhances the value and appearance of the dwelling. Furthermore, Advancements in technology have introduced new considerations for branch circuit design. The increasing use of smart home devices, electric vehicles, and renewable energy sources requires careful planning and design to ensure that the electrical system can accommodate these new loads. Smart home devices, such as smart lighting, thermostats, and appliances, can significantly increase the electrical load in a dwelling. It is important to consider the power consumption of these devices when calculating the total load and determining the number of branch circuits required. Electric vehicles require dedicated charging circuits, typically rated at 240 volts and 30 amps or higher. These circuits must be sized to accommodate the high power demands of electric vehicle charging, and they must be protected by ground fault circuit interrupter protection. Renewable energy sources such as solar panels and wind turbines can generate electricity that is fed back into the electrical grid. The installation of these systems requires careful coordination with the local utility company and compliance with all applicable codes and regulations. In conclusion, determining the number of branch circuits required for a single-family dwelling involves a comprehensive understanding of the National Electrical Code, as well as careful consideration of the specific needs and usage patterns of the occupants. By following the guidelines outlined in National Electrical Code Article 220 and consulting with a qualified electrician, it is possible to design and install a safe, reliable, and efficient electrical system that meets the needs of modern living. This includes properly calculating general lighting loads, small appliance circuits, and laundry circuit requirements. Also, be sure to calculate additional circuit requirements to account for smoke detectors and carbon monoxide alarms, bathrooms, door receptacles, and electronics to protect them from surges and voltage fluctuations. Using demand factors and considering non-coincident loads allows for more accurate calculations. Other applicable sections of the NEC are Article 210 on branch circuits and Article 408 on panel boards. Install all branch circuits in a neat and workmanlike manner, and consider the increasing use of smart home devices and electric vehicles when planning branch circuit design. By following these guidelines, you can help ensure the safety and convenience of those that will be using the electrical system.